So this first one, write down please. We have x squared plus y squared equals 4, and I see a lot of perfect graphs for this circle. So that looks really good. It's fine, right? So, all right. So write down please. For x squared plus y squared equals 4. What's the center of this circle? It's 0, 0, which we also call the origin, right? Okay. Anyone know the radius of this circle? 4 is a great guess, right? It is 2. It's not the 4 is, well, 4 would be the diameter, but it's not because you don't have the 4, you square root the 4. Yes? Okay, and that's a fair question because you haven't been taught this yet, right? So I'm kind of curious how all these students knew it was 2 without ever having a lesson on circles. So let me just draw a quick circle here. It's not great, but there you go. Okay. So how, those of you who got this, which is almost every single group, how did you know the radius was 2? How did you know that you needed the square root of 4?
Because everything else is squared.
Because everything else is squared, you just assumed? Okay, it was a safe assumption for this. Yeah. All right. Has anyone learned circles before? Don't you know the geometry a little bit? Yeah.
I say we skip over.
Omar felt that.
Oh my God.
Oh, goodness. All right. So, next one. So, for this, just in case you're wondering, the center is 0, 0, and the radius is 2. For this next one, we have the equation x minus 1 squared plus y squared equals 4. Now, we've been doing a lot of translations over the last week. Excuse me for one moment. We've subtracted 1 from the x. Based on all the experience you've had so far with translations, how do you think this is going to shift our circle?
To the
To the left?
To the right.
To the right?
Just like how we do with
down? It's going to be to the right, one place, right? So when we graph this circle, now we're shifting our center quite down to the right one place, and then our radius, does our radius change? No, the radius is still 2, so I go out 2, up 2, left 2, down 2, and connect the dots, pretend that that's connected. So, anyway, so now for this one, our center, instead of being 0, 0, our center is going to be 1, 0, and our radius is still 2. All right. Today we're doing section 3.8, which is transformations with circles. Transformations with circles. Yes. So technically you can reflect anything. However, when you reflect a circle, it doesn't really change it, and still the same circle. Yeah, you can sit over there. So, and part of the reason that the reflection doesn't change anything is because the negative ends up being squared. No matter where the negative is, it ends up being squared. Joey, did you have a question?
I was just going to say, I'm not going to be here.
That's good to know. Okay. So all of you who are going to be out tomorrow, I will provide you with tomorrow's homework when we get towards the end of class. Okay. So standard form of an equation of a circle that is centered at the origin is x squared plus y squared equals r squared. What does the r stand for?
Radius.
Radius, which is the distance from the center. Distance from the center. So technically, the definition of a circle is the set of all points equidistant from a fixed point. The set of all points equidistant from some fixed point. The fixed point would be the center. So if I go a distance, for example, if I have the center right here, and say I set my distance to be 3, if I take the set of all points that are 3 units away from the center, oh look, I drew a happy face, then I get a circle. It's the set of all points equidistant from the center. Now, is the actual center technically a part of the circle? No. But the center is very useful in that it helps us graph the circle, right? So I always, when I have to graph a circle, I start by plotting my center, and then I use my radius to go like out from there. So a compass?
Compass, yeah.
We are not going to use a compass. You can, if you have a compass, you are welcome to use a compass. I don't need your circles to do that for me. Yeah, I'm okay. I'm okay with imperfect circles. So for this equation, we would have x squared plus y squared equals, what is the radius of that circle?
3.
It's 3. So what do I put here? X squared plus y squared equals
3 squared.
9. 3 squared, which is 9, right? Does everyone understand where the 9 came from? Okay, so that's your radius squared. Good. But what if we want to shift the circle around, like move it around? So this is where circles end up being a little bit different from all the other functions we've studied so far. Technically, is a circle a function?
No.
No, because it passes
doesn't
way
pass
over
the
twice.
vertical line.
Very good. Circles are not functions. They don't pass the vertical line test, right? So all of the functions we've studied so far, we've studied quadratics, well, linear, but in this unit, we've studied quadratics, absolute value, and square root. All of those functions had something in common when we presented them. They were all solved for y. Circles are different. Standard form is not solved for y. Standard form has x's squared and y's squared and r's squared. And the reason that we do this for standard form is because it's so much easier, because when the equation looks like this, we can look at it without having to do any work at all, and we know the center and we know the radius. So when you can just look at the equation and you know the center and you know the radius, life is easy. When you solve this for y, it's not near as pretty. So traditionally, we don't solve circle equations for y. We could. You'll see when you get into calculus, you're going to have to. But right now, we don't solve them for y. We just keep them like this. So because of that, in the past, when we did a left-right shift, we had to do the opposite sign. But when we did an up-down shift, we just kept the sign the same because we were adding to the outside. We're not adding to the outside anymore. So when we do our left-right shift, we subtract from the x, we do opposite sign. When we do our up-down shift, we subtract from the y, and now we're going to do opposite sign. So, and here's what I want you to think to yourself. If I were solving this for y, somewhere along the way to get y by itself, I'd have to add k to the other side. So if it was solved for y, then it would be a plus, right? But because it's not, it's opposite. So what ends up happening is if you have x minus h squared plus y minus k squared equals r squared, then your center is the coordinate hk. So it's opposite signs of what you see in the equation. And then your radius is r. So if we had, what I want you to do is take a second, see if you can figure out the equation of this circle. See, talk to each other just on paper. Find the center, find the radius, write the equation.
Oh, yeah, you're right.
Y minus is going to be 3
What do you think? What's the center? Subtract the negative. So we have to do opposite of both of those. So you're actually your y is x, but your x is r. Yeah. And then make sure you put squares.
Yeah. The H is how far left.
Oh.
Yeah, it's not.
Okay. Avi, how you doing? Did you have a good weekend? Not on Saturday because of hockey? Yeah, I'm sorry.
That was great. Basketball team won.
Basketball, yeah.
That was like,
Yeah. Hey, Avi, can you tell me the center of this circle? Very good. 4, -3. Does everyone agree? Okay. Quiet, please. Now remember, this is your H and your K, right? 4, -3. So this means I'm shifting 4 to the right. So I'm going to have x, what's going to go in here? -4. I'm shifting 3 down, so I'm going to have y +3. Got to change the sign on both of them. When you're in those parentheses, like nested with the variable, you got to change the sign on both. Okay. And then, what's the radius of this circle? 3. So what number am I going to put here?
3 squared or 9?
3 squared or 9. Very good. Nice description. All right. How are we feeling about this? You ready to try some more?
Yeah.
All right. Okay. Here's what I want. I have 2 graphs on the board. I want you first on paper to see if you can figure out these equations, and then I want you to transfer them, the answers only, to your whiteboards. I'm going to give you a couple of minutes to figure them out. Make sure you're talking to each other, working together with your groupings, okay? Oh, and it looks like all of the boards matched. So for the first circle, for circle A, the center was the point -6, 2, and the radius was 1. So we end up with x plus 6, because it's 6 units to the left, right, squared, plus y minus 2, because it's 2 units up, and we do the opposite, squared equals, and then the radius squared is 1. For part B, we just did this circle like a minute ago, so I don't know why we're doing it again, but the center is at 0, 0. The radius is 3, so the equation is x squared plus y squared equals 9. All right. Which all of you got, so well done. Okay, so the next two, I want you to do on paper, write the standard form of a circle with a center of 3, -2, and a radius of 6, and then write the standard form and equation of a circle that, passes through the point -2, 4, and has a center at the origin. So what I want you to do part, let's call these A and B. So part A, I know you can all do, just do it in your notes on paper. Part B, I want you to sit, discuss, and then if you figure out an answer, I want you to put the answer on your whiteboards. I'm going to give you maybe 3 minutes to discuss it with each other and see if you can come up with something. We have a center at 3, -2. Whenever I write an equation of a circle, I write something squared plus something squared equals something squared. I kind of write like a template, and then I fill stuff in. So my first part, I'm going to have x, and then what's going to go here? -3. Do the opposite of the center. Here I'm going to have a y plus 2, and then what do I have to do with the radius? Square it, so you get 36. Are there any questions on letter A? Everyone feels comfortable with letter A? Good. What I see on the boards, for those who put letter A on the boards, it looks good. So, okay, yeah, looks nice. All right, let's talk letter B. So I saw several students doing something that I thought was very wise, which is they plotted the center at the origin, and then they sketched a graph and put the point there, and then drew a line segment because the radius of that circle would be the same as the length of that line segment, right? So how do we find the length of this line segment? Oh, if only we knew a theorem. So one of the, oh, yes, Avi.
Yeah, so I think it's like x1 minus y1 squared plus x2 minus y. Yeah, plus y squared. Yeah.
So what you are trying to quote to me is called the distance formula, right? Quiet, please. And the distance formula is based on a wonderful theorem that we have used for a long time. Anyone know what this theorem is called? Pythagorean theorem, named after Pythagoras, right? Okay, so this length is 2, this length is 4. But what Avi was trying to say was if you do x2 minus x1, the reason you do x2 minus x1 is to find this length, if you didn't know it. Like, hey, -2 minus 0, right? That gives me the length, and then I square it, right? 4 minus 0, that gives me that length, and then I square it. So what you were saying was, hey, subtract the x's so that you get the length of that line segment. Subtract the y's so you get the length of that line segment, and then this squared plus this squared equals my distance squared. So either way, so we do Pythagoras, so we do 2 squared plus 4 squared equals our radius squared. So 4 plus 16 equals r squared. So my question to you, if I get that r squared is 20, do I have to find r?
No.
Why not?
Because it's square.
Because the equation is r squared, right? So my equation would be x squared plus y squared equals 20, because 20 is r squared, and I'm done. Don't have to find the square root, don't have to simplify the radical, just r squared, done, life is good. Okay. All right, so well done. Most of you guys got this. I'm very pleased. All right, 2 more, and then we're going to move into something new. This first graph, in order to graph it, and this I just want on paper, just a rough sketch is fine. In order to graph it, what are you going to have to do first? Divide everything by 5. So when you divide everything by 5, x squared plus y squared equals what is 80 divided by 5? 16. What's the center of this circle? 0, 0. What's the radius? 4. When I have to graph a circle, I plot my center, and then I go out by my radius, like left, right, up, down, and then I just connect the dots. It doesn't always look beautiful.
I mean,
But you know what? That's okay. Like it's fine. So on the second one, what's the center?
3, -1.
Are you sure?
Yeah,
Yes.
sure, of course. For sure.
Yeah?
100% is price.
100%?
110.
110%. It's the radius. 3. So I go out 3. I'm off the chart here. That's okay. 3, 3, 3, and then connect the dots. And there's your beautiful circle. Okay. All right, are there any questions on going from a graph to an equation or from an equation to a graph? Ready to take it up a notch? Okay.
Oh my shifting.
So we're going to move into ellipses.
Everything was 4.
Now, quiet down, please. Before we do this, let's pretend that it's just a circle, you're looking at this,
Oh, come on.
and let's just pretend these two numbers were the same. If these two numbers are the same, and I wanted to graph this circle, what would I do first just to clean up my equation? Multiply both sides by 4, and I'd get x squared plus y squared equals 4, right? So this would be a circle with a radius of 2, right? Okay. So if I take my circle equation, radius of 2, and I divide both sides by 4, what I end up with is this, right? So this is what I just showed you as a circle. This is also a circle. Now, what happens if the numbers underneath the x and the y are not the same? Then it's not a circle, or you can think of it as a dilated circle, right? But it's really not a circle. We call it in math, we call it an ellipse. It's like an oval, right? Okay, so this is how I like to graph ellipses. First thing I do is I plot the center. Now the center of an ellipse is just like the center of a circle. It's whatever number is being subtracted from your x and whatever number is being subtracted from your y. So in this case, since we're not subtracting anything from x or y, what is the center?
0.
The center of this ellipse is 0, 0. So the first thing we do is we plot the center. The number under the x tells you how far you're going to go from in the x direction, horizontally from the center, but you've got to take the square root of that number because it was your r squared, right? You've got to take the square root. So we're going to go, whoops, I can write the word left and right by 2. So I go right 2, left 2. So horizontally, the number under the x tells you how far you're going to go left and right. Move this down. The number under the y tells you how far you're going to go up and down. How far do you think you're going to go up and down?
4.5.
By 3. It's okay. You're thinking halving. Yeah, we're square rooting. So we go up 3, down 3, and then we connect the dots, right? So then we connect the dots, and pretend that that goes through there, and we get an ellipse. Yes, ellipse is actually like the mathematical term for oval. Yes. Now,
The 1.
what about the 1? Oh, what does the 1 do? So the 1 doesn't do anything. All what we call, so a circle and an ellipse are two types of what we call conic sections. Now, the reason they're called conic sections is because if you take a cone, does everyone know what a cone looks like? Yeah. Okay, if you take a cone and you slice it, depending on how you slice it, you end up with different shapes. Shh, quiet, please. If I take a cone and I slice it this way, I get a circle. Right? My cross, like what the slice, if I'm looking down on the slice, it's a circle, right? Take a cone, slice it, you get a circle. If I take a cone and slice it in a slightly slanted way, I get an ellipse. If I take a cone and slice it parallel to one of the sides, I get a parabola. And if I take a cone and take like two cones, one upside down from the other one, and slice vertically, I get what's called a hyperbola. So there are 4 conic sections. All conic sections can be written as equations equal to 1. And there's a reason for that for standard form, but we're not going to get too deep into that. Right now we're just learning circles and ellipses. Circles we could always set them equal to 1, like put the 9 under here, the 9 under here, and it just tells them to go out horizontally by 3 and up, vertically by 3, right? And that would be fine. It's just that most people just write equals the radius squared. It's just faster, right? But for ellipses, we write it equal to 1 because this standard form is the easiest to know how to graph it, right? Because the numbers are different. So anyway, oh, yes, Max. For ellipses, you want the number to always be 1. Yes. I have a little bit of trivia. All right? So do you guys remember when we learned parabolas? And I talked about what's called the focus of the parabola. Okay. And I told you a little story about parabolas. We related it to a couple different real-life objects. Ellipses have 2 focuses. And the plural of focus is foci. So if you ever hear the word foci, it means it's the plural of focus. Focus. It's not focuses, it's foci. So the foci of an ellipse are these dots, kind of like there and there. They're along what we call the major axis of the ellipse, and so the longer axis, right? So we have these foci. Now here's what's special about the foci of an ellipse. Anything that gets projected out of one focus automatically gets sent to the other focus. So no matter where it hits the ellipse, it's going to get sent to the other focus. Even if it goes like all the way down here, it's going to bounce back and hit the other focus. No matter where you get sent in an ellipse, now vertically it's going to hit both of them. But anyway, so all the other points, if I go out of here, I'm going to get bouncy here, and vice versa, right? So there's a fun application that you can do with that. There's actual real applications, but the fun one. So I did this when I was a little kid. So I grew up in the suburb of Chicago. And so when I was a little kid, we used to take field trips from time to time to the various museums in Chicago. One of them is this amazing museum called the Museum of Science and Industry. Has anyone been there in Chicago to the Museum of Science and Industry? You? Maggie? Yeah? Yeah, Mary? Okay. Did you like it? It's pretty awesome, right? Did you go in the sub? Do you know the submarine I'm talking about? No? So they have this captured German submarine that was, it's like almost miraculous that they were able to take it from the Atlantic Ocean and then through the Great Lakes and all these canals and everything and get it to Chicago. And so when I was a little kid, you walked out the back of the museum down this little pathway and you could go inside of the U-boat, right, and see what it was like in there. Since then, they have now built this incredibly beautiful wing around the U-boat so that it's all enclosed inside the building, and it's got all these amazing pictures and stories and all this kind of stuff. It's so cool. But anyway, I digress. So here's what else they have in Museum Society. Not my favorite part was always the baby chicks. They do this whole farm part, and you can watch little chickens hatch. It's fun. But anyway, there's a part where they have an ellipse. And so what you do is they have footprints on one part of the room, and then they have footprints 150 feet away on the other side of the room, right? And so you stand here, and you have a friend stand on the other footprints, and they have built this plexiglass elliptical thing over you and over the other footprints, and then the person that's 150 feet away can hear what you're saying because your sound is projected to the other focus of the ellipse, right? So it's kind of fun. There is an elliptical room. I don't remember honestly if it's in the U.S. Capitol building. It's in one of the big Washington D.C. government buildings that has an elliptical ceiling, and there are whisper points on the floor that they've identified.
Are you talking right now?
I don't think this room's an ellipse.
No, this room is not an ellipse.
Do ASMR math.
So you want to do what?
ASMR math.
I don't know what that means. ASMR math.
Just whisper the entire time.
Oh, whisper the whole time?
Oh,
Alright. So anyway, so here we have an ellipse. It's been shifted. I want you to see if you can figure out the equation of this ellipse. So take a minute in your groups, figure out the equation of this translated ellipse. Question, Michelle, what is the center of this ellipse? And I know it's hard to see from the back. It is 3, 1. And to find the center of an ellipse, there are two axes of symmetry. There's a horizontal axis of symmetry and a vertical axis of symmetry. Where those two axes intersect, that's the center. So well done in figuring that out, right, without any instruction. So good job. So we got the center is 3, 1. Now before you tell me the rest of the equation, I'm going to, let me erase this too. There we go. When I write an equation of an ellipse, kind of like when I write an equation of a circle, I tend to go something squared over something plus something squared over something equals, what is an ellipse size equal to?
1.
1. Okay. So, Michelle, let's just focus on the center. What's going to go in here? X will be plus 3 or minus 3? Yes, very good. You do the opposite. Okay? All right. What's going to go in here? Yes. Fantastic. Right? Okay. You're rocking. All right. So now we got to figure out what numbers go under here. Right? So we look at the stretch horizontally from the center to the edge. How far is that? That's 4, right? So what do I put under here? Do I put a 4? Michelle.
I thought you were asking.
Yes! Very good. We square it. Fantastic. You're almost done. Okay, almost off the hot seat. So for the next one, we're going to do the vertical stretch or dilation. Michelle, what's this distance? It's 3. So what's going to go under the Y? Yes! You just did the whole thing. Beautifully done. Beautifully done. All right. How are we feeling about that?
Good.
Okay? All right. Okay, last one. You're going to sketch this graph. Then we're going to do some solving. It'll be super fun. All right? So we have a graph to sketch, a few equations to solve, and then you will be free to start doing homework and that kind of stuff. So take a minute so you can sketch this graph. All right, Jose, first question. What is the center?
-1, +2.
Does everyone agree? -1, 2?
No.
Yes. All right. Okay, you're 1 for 1. Now, next question. From the center, how far do I want to go to the right or the left?
2.
Right or left?
Right.
No, okay, I'm not asking you right or left. I'm saying how far. Look at your X.
Oh, you want to go 5 to the right.
Yes, 5 to the right. 1, 2, 3, 4, 5. And 5 to the left. 1, 2, 3, 4, 5. Does everyone understand how Jose got 5? Does everyone understand how Jose got 5?
Yeah.
All right, Jose, next part. Up or down? How far am I going to go?
2.
2. Very good. How'd you get 2?
4 to square root.
That's good. Yeah, don't be nervous. It's okay. All right, we connect. Any questions? All right, I have 3 equations that I want on your whiteboards. Yes?
Can I ask you a question?
Yes? Yeah, here, I'm going to. For letter A, in order to solve this for Y, what is the first thing that I need to do? Subtract the 2x.
What are the like? I thought you talked about
What? Let's just go backwards.
All right. Now what do I need to do? Divide by -3. Now, all it said was solve for y. So if I leave my answer 6 minus 2x over -3, is that Right, or is that wrong?
That's right.
That's right.
Wrong.
Solve for y. However, if we were trying to say, like, graph this equation of this line, it would be nice if it was cleaned up a little bit, maybe written in slope-intercept form. So let's go ahead and divide each term by -3. What's 6 divided by -3?
-2.
-2. What's -2x divided by -3?
2x.
Positive 2/3 x. So the group that got 2/3 x minus 2, which was, okay, yes. You guys don't have an x.
Didn't we get
You
that?
showed 2/3 minus 2.
That's my
Okay,
bad.
it's okay.
Omar.
And then Isaac goes to the center. You guys got it.
We got it.
So well done. You guys got it up front? Yes? Beautiful. All right, so very well done.
Right there.
All right, the next one. What's the first thing that we do?
Figure it out.
No. Add 3. So we have y plus 1 squared equals x plus 3. I have isolated the squared term, which means what can I do to both sides? Square root them. When I square root both sides, first, what's the square root of y plus 1 squared? Y plus 1. When I write the square root of this side, what has to go in front of it?
Plus or minus.
Plus or minus. Plus or minus. What's the last thing I have to do? Subtract 1. So I end up with y equals plus or minus the square root x plus 3 minus 1. Can I put this as a plus 2 inside of the root?
No.
No. This is a horizontal translation. This is a vertical translation. Totally different. Can't put them together. All right. So not a lot of groups got that one. I'm seeing none. Not a single group. You say it's just the plus or minus as though that plus or minus is so insignificant, but that plus or minus is a big deal. Okay, that's half the graph, right? Okay, last one. What do I have to do first?
Subtract 2.
Subtract 2. So I have the square root of 1 minus y squared equals x minus 2. I have isolated the root. What do I do to both sides? Square both sides. Be very careful when you square the right-hand side. Is this x squared minus 4?
No.
Is it x squared plus 4?
Yes. No.
It's x minus 2 squared. You have to square the whole side. You don't get to just square each term. You got to square the whole side, right? And we know that x minus 2 quantity squared is not x squared minus 4, right? Or x squared plus 4. It's x squared minus 4x plus 4.
Oh, yeah.
So, okay. So what's the next thing that we have to do?
Subtract 1. Subtract 1.
Subtract 1.
And then multiply by -1.
So we have negative y squared equals x minus 2 squared minus 1, and then multiply by -1. Y squared equals negative x minus 2 squared plus 1. Almost done. Square root. What has to go in front of the square root? One of you gonna be okay? Okay. Yes, Anthony.
I took a look at. Oh yeah, you guys did what you did. If his price didn't do it like that.
So inside of your you have a plus or minus, right? Inside of the root you have negative x squared plus 5. And the way that you get negative x squared plus 5 is if you say x minus 2 quantity squared is equal to x squared plus 4, and then add the 1. So you've lost your minus 4x. So you're really close. You were so close. I would say yours is the closest one of the whole room. So well done, right? Take satisfaction in knowing this is not easy to do, and you did really well. All right.
You don't have to. Because like I didn't isolate this. I kept 2 on the same side. You're able to do that.
When you squared both sides?
Yeah.
No. Again, you've got to square the whole side. So yeah, that might have been where things went bad. Okay. All right. Good. So yes, we're done. Okay. This would be like a bonus problem. If you wanted to try to solve this for y, it's really fun.
Well,
It's tempting. Okay. I'm going to solve it for the recording, but first I'm going to hand out your. Okay, just for the recording, I'm going to go ahead and solve this for y. So we're going to start by subtracting this whole big x term from both sides. And we end up with y plus, y minus 2 squared over 4 equals 1 minus x plus 1 squared over 25. Then if we multiply both sides by 4, we get y minus 2 squared equals 4 minus 4 25ths x plus 1 squared. Square root both sides, put a plus or minus. This x plus 1 squared. And then the final thing you have to do is add 2. So you end up with 2 plus or minus the square root 4 minus 4 25ths times x plus 1 squared. Now there are more things that you can do to simplify the radical, but I'm not going to get into it today. Right now, if you got here when you were solving for y, well done, because that's pretty awesome.